Okay, so let's have another example. And in this example, we are going to have a disk, has a mass of 50 kilograms and has an angular velocity of 30 radian per second. When it's going to be brought to a contact with the horizontal surface at the point C. So now, let me explain this situation once again in very few words. The disk was already rotated. So now the omega 1 is given as 30 radian per second. This was rotating, and we're going to bring it down. It's going to have contact with the ground at the point C. And this will cause a friction force to be happened due to the normal force which of the weight of the uh, disk itself. And the bar will prevent it from moving. Okay, it prevents it from rolling until it's going to be stopped. If the quotient of kinetic friction given as 0.2, determine how long time is going to take for the disk to stop spinning. Neglect the weight of the links. So you can see that the free body diagram is going to have forces in x direction and the y direction. In the x direction, we are going to have the tension at the link AB. That's going to the right, to the left. And we have the friction force, which is going to the right, because that's spinning to the clockwise direction. So friction force expected to be to the counterclockwise, to the opposite direction. Now we know that the N and the friction force have a relation that the friction force is equal to the normal force multiplied by the quotient of friction. So we have 0.2 here, we have the NC, so this will be 0.2 NC. The radius is given as 0.2, and this will help me to find the value for the IG. And the weight is 50 times 9.81, and this will make it 490.5 in Newton, and that's vertical downward, while the NC is vertical upward. Now, again, what we are going to do is we're going to apply the two equations for the linear momentum. Why we do the two equations now? Because now we are going to have vertical forces, okay? And we don't have velocities there. And this will help me actually to find the value for the NC. In the x direction, we're going to have two forces, negative and positive value. And we can find actually the value for the TAB. Now, the problem is that we don't know the time yet. We don't know what the time yet, but we know at least that the velocity one is given to us because we have the omega is equal to 30 radian per second. And we do have the radius is known, and we know there's no slipping to be happen because the bar will prevent the things from slipping. Okay, and we know that the omega 2 is going to be equal to 0 because we say it's going to be stopped at the end, stop spinning at the end. So now once again, if you write down the set of the equations, this will be for the linear momentum. We know the forces in the x-axis, two of them. We know the force in the y-axis, we have two of them. One of them is known, two of those unknown. So we start with the y direction first. For the velocities in the y direction, both should be equal to 0. But that's my opinion because we don't have the disk moving upward and downward. But actually, even the anyway, we'll see how this is going to be done. Now, for the angular momentum, we can calculate the hg1 and the hg2, and we can calculate the moment around the point G, mainly because we want to avoid having the tension force, which is unknown. In all the cases, if at the A or at the G, we are going to have one unknown force. Okay, so the equation steps has given is the forces in the x-axis, the forces in the y-axis, and the momentum around the point B, which is the center point. And the answer will be that the time is going to be equal to 1.523 seconds. The TAB is going to be 98.1, and the NC is going to be 490.5. That's obvious that in the y direction, we're going to have the velocity is going to be equal to 0, and this will tell me that the for the sigma of the forces to the y direction is equal to 0, and this will be equal to the NA minus the weight is equal to 0, and this will tell me that the weight is equal to the NC. Then I can find the friction force, repeat the process for the x direction, and I can find the tension of the point AB. length AB. Then I can calculate the moment to find the time. Okay, so we are going to start with these steps. First, we need to sketch the free body diagram and the kinetic diagram. So this was the state one. We had the rotation to be happen, and we have the IB multiplied by the omega 1. And then suddenly we are going to have it in contact with the ground at the point C. This will create the friction force due to the normal force. And we're going to have at the center the link AB force, try to prevent it from slipping, and the weight going downward. On the other state, we're going to have the IB omega 2 is what we have. Now, let's start to list the known and the unknowns we have here. So we know the mass, we know the mu k, we know the omega 1, and we know that omega 2 is equal to 0. The unknown are going to be the NC delta T and the TAB, and we are going to assume be positive in the calculation. So now we're listing the equations once again, and we're going to put the parameters within. So we choose the two equations for the linear and one equation for the momentum. First thing we are going to do is calculating the IB. We know the radius, we know the mass, and we can simply just put everything in. And we're going to get that the value of the IB is going to be equal to 1 kilogram meter square. Now, let's start to apply the equation for the forces in the x direction. Sorry, in the x direction. So here we know that. Oh, sorry, that should be the y. That should be the y. FCTAB. Oh yeah, actually it's not moving to the x-axis as well. Yeah, so the velocity on the x-axis is also going to be 0. So this one is 0, that one is 0. Then we're going to have only the friction force and the TA force. Now, whatever the time is, but in all the cases, we are going to have these values of the FC and the TAB can be found. So I can simply mention that the mu K multiplied by the NC multiplied by delta T plus the TAB multiplied by the delta T is equal to 0. So I can simplify the delta T and I will get that the mu K NC is equal to TAB, or the TAB is equal to the mu K multiplied by the NC. That's what we can get from the first equation. Okay, we know the mu K is equal to 0.2. So if we're going to take it to the other side, the TAB is going to be negative of the value for the friction force. Negative because it's going to be on the opposite direction, as you can see from this diagram. Now, we couldn't find the value for the TAB or the NC, so we need to do the direction Y, where the two velocity once again is going to be equal to 0, because this roller is not going to go upward or downward, left or right. So we repeat the same calculation. This is 0, this is 0. Here we're going to have the forces in the y direction is going to be the weight and the normal force. Again, we're going to do the integration. We're going to find that the first part here is going to be W multiplied by the delta T. And of course, the W is going to be negative, so it should be negative here. And the NC is going to be positive multiplied by the delta T, or that equation. And this will tell me that by simplifying the delta T, that the NC is going to be equal to the weight. Good. Now we have the NC value. Multiply that by 0.2 is going to give me the TAB. So done. We fixed for the TAB and for the NC now. Now the third thing is going to be about finding the time itself. Now everything is known. Now we know the force. Okay, this force. And we know the IG. We know the omega 1 and omega 2. So we can go to the other equation and find the parameter for the H1 and the H2. And we can find the moment around the point B, which is mainly going to be just this force, the FC, multiplied by the radius. So we're going to write down the equation. That will be my equation. Now the HB1 is the IG omega 1. The HB2 is the Ig omega 2, and the moment can be found is going to be equal to the Fc multiplied by the radius. Okay, so now we know the omega 1 is equal to 30. We consider that the Ig omega 1 is negative value, and we can now start to do the calculation. The Fc is given to us. The R is equal to 0.2. So we write down this equation. Now we can see that in equation 3, only delta T is unknown. So by solving, we can put the NC and the omega 1 in this equation. And the omega 1 is 30. The NC is 191, I think. And thus it will give me that the delta T is going to be equal to 1.53 seconds. And from the equation 1, we will find that the TAB is equal to minus 98.1 Newton. That's it. Okay, so we finished the equation number 2, and we're going to go for the question number 3.